See, I'm going to take up a question which was once asked in a competitive examination. The question is, human albinism is the absence of pigment from the hair, skin and eyes. Determine from the pedigree given below whether this trait is a dominant, recessive or sex-linked gene inheritance. So this one is the pedigree in which 3 generations are shown. And in the second generation, there is a male person who shows the albinism, that is absence of pigment in his hairs, skin and eyes. And then in third generation also, there is a male person who shows the trait. So we have to tell whether it is an autosomal trait or a sex-linked trait, and if it is autosomal, whether it is dominant or recessive, and if it is sex-linked, then whether that sex-linked allele causing the trait is a dominant one or recessive. Now, if we see this second generation person who suffers from albinism, this one is a male person. And if we consider that this male person is suffering from albinism because of sex-linked inheritance pattern, so we can actually rule out this possibility. Let me take the pointer and we shall be able to understand this aspect. So this second generation male individual suffers from albinism, and if it is a sex-linked trait, then this male will be inheriting his X chromosome to the next generation daughters. So this male is married to a woman and they have 3 children, but daughters are all right. They could be carrier in case. And since male inherits his X chromosome only to daughters, he will be inheriting actually his Y chromosome to his son. So the possibility that this will be a sex-linked trait is not there at all. So it becomes clear that the trait would be autosomal in nature. Now we have to see whether it is dominant or recessive in nature and what could be the probable genotype of these persons and also their parents. This all we can understand by discussing the aspect. See, this fellow, if it is suffering from albinism and if we come to know that it is an autosomal trait, then genotypically this fellow could be small a if we consider that small a allele in homozygous condition results into albinism. And in that situation, if the genotype of this male is small a, then his parents, his first generation, parents would have been carrier. So this fellow would be carrier. The mother of this second generation male will also be carrier. Only in such condition, uh, this fellow could be small a in genotype. And he gets married to a woman, but that woman will also be carrier because in the next generation, recessive allele has to go from both sides. So from male side, recessive allele will definitely be going, and from female side also, if she is carrier, then the recessive allele will go. So we can discuss this aspect by seeing the same pedigree, but here I have assigned genotype to some of the individuals. We are seeing the second generation male suffering from albinism, so his genotype will be small a. And if he gets married to a woman who is carrier, then in that situation they will have children who could be small a, and their one of the male child is actually showing the trait that is albinism, and the daughters of this couple are actually carrier. They will definitely be carrier because the small a allele would be coming from male side, and capital A allele has come from the mother side, from the female side, so they are actually carrier. And if we consider the first generation parents, then they are obligate carrier, they are definite carriers. Only in that situation the small a allele would be coming over here. And if we consider other siblings of this male, then they could be homozygous capital AA or they could be heterozygous. Chance that any person is heterozygous in nature would be 2 by 3, because among normal persons, if someone is heterozygous, if we want to calculate the possibility of that situation, whether someone is heterozygous, for that we can simply say that the chance of being a person heterozygous in these uh, 5 cases would be 2 by 3. Anyway, we have simply assigned the genotype of some of the persons uh, for which we can say with complete certainty the first generation parents, they are actually carrier in nature. That is why they have 25% chance that their children could be even albino, and this has happened with one of the male children. And then entire thing just I explained about it, so we can finally conclude that this pedigree shows that albinism is a is an autosomal trait, and it is recessive in inheritance pattern.